Hi, this is Gangadhar from Giraj College. Lecturer in mathematics. Today's topic is BSc second year real analysis. In the real number system, first we know infinite numbers. We know infinite numbers. So what are those numbers? We know infinite numbers. So what are those numbers? So there are infinite numbers, we know. So we know the numbers are 1, 2, 3, 4, so on. So fractions, we know. Square root values, we know. Next, some constant values also we know, like pi, e, so on. So in this way we know infinite numbers. So in those numbers, so which numbers are belongs to the which number system? So for now we first start with the natural numbers. So natural numbers. So what type of numbers are called natural numbers? So natural numbers are 1, 2, 3, 4, so on. Numbers are called natural numbers. 1, 2, 3, 4, so on. Numbers are called natural numbers. So in the natural number system, we define mathematical induction. In the natural number system, we define mathematical induction. So what is the statement of mathematical induction? So mathematical induction statement is first, given statement is true for 1. Given statement is true for n equal to 1. So 1 is belongs to n. Next, second, so given statement is true for n equal to k, and we show that it is true for n equal to k plus 1. So this properties we define on the natural number system. So and these properties are called mathematical induction. So mathematical induction means first we show that given statement is true for n equal to 1, and next given statement is true for n, and we show that it is true for n equal to n plus 1 also. So now next number system is whole number system. So whole numbers are 0, 1, 2, 3, 4, so on. Numbers are called whole numbers. Next, integers, set of all integers. So integers means integers are 0, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3, so on. These numbers are called integers. 0, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. These numbers are called integers. So in these integers, again we define even integers, odd integers, positive integers, and negative integers. So now what are the even integers? So even integers means two multipliers. Two multiple integers is called even integer. So two multiple means even integers are set denoted by 2z, and even integers 0, plus 2, minus 2, plus 4, minus 4, plus 6, minus 6. This way we define even integers. Next, odd integers. So odd integers means 0, plus 1, minus 1, plus 3, minus 3, plus 5, minus 5, so on. This way we define odd integers. So next, positive integer. So when we say that given number is positive, so if the number value is greater than 0, number is greater than 0, then that number is called a positive number. And same way, less than 0 number is called a negative number. So a number which is greater than 0 is called a positive number. Positive number means greater than 0 numbers are called positive numbers, less than 0 numbers are called negative numbers. So now greater than 0 integers, so that's set denoted by z plus. Greater than 0 integers are 1, 2, 3, 4, 3, 4, 5, so on. So these numbers also called natural numbers. So now z plus equal to n. So less than 0 numbers are called negative integers. So z minus 1, minus 2, minus 3, minus 4, so on numbers are called negative integers. So this way we define integers. Integers are 0, plus 1 minus 1, plus 2 minus 2, plus 3 minus 3, plus 4 minus 4, so on. Again in this integers we have positive values, negative integers, next even integers, and odd integers also we define. So these are all integers. So now next number system is the rational numbers. So rational number. So what type of number is called a rational number? So rational number means a number, it is the form p by q, means it is fraction. So p by q. So number, it is the form p by q, and p comma q belongs to z, and q is not equal to 0. So if denominator value not equal 0, then we say that that number is defined. So if denominator value 0, then we say that that number is not defined. So denominator not equal 0 means that number is defined. So rational numbers are the form p by q form. P comma q are integers and q value not equal to 0. Suppose we will take 0. 0 is a rational number or not? 0 is a rational number or not? So 0 is a rational number. Since here we write 0 by something. 0 by something. Something value not equal 0. So 0 by something is 0. Something means, so that value not equal 0. Means that number is defined. So it is p by q form and q value not equal to 0. 0 by 1, 0 by 2, 0 by 100, so on. This way we define 0 values. So 0 is a rational number. Next, suppose we will take 2. So 2 is a rational number or not? So 2 also rational number, 2 by 1 form. So here in the definition of rational number, p by q such that p comma q belongs to z. P comma q are integers. So p comma q are integers means all integers are rational numbers. All integers are rational numbers. All integers are rational numbers. So now next number system is irrational numbers. So irrational numbers means, so here a number which has no perfect square root, a number which has no perfect square root is called a irrational number. A number which has no perfect square root is called a irrational number. So irrational numbers, example, root 2, root 3, root 4, it has perfect square root. Root 4 value 2. So root 4 is not irrational. Root 5, root 6, root 7, root 8, root 10, root 11. So this way we define irrational numbers. So now rational numbers are the form p by q form, and irrational numbers are the form a number which has no perfect square root is called irrational numbers. So now the number system. So now the number system is real number system. So what type of real numbers are called real numbers? So what is the definition of real number? So what is the definition of real number? So we know so many numbers, infinite numbers we know. So what are they means? We say that those numbers are real numbers. Directly we said. So we knowing numbers are called real numbers. So simple definition of real number is a number which is defined is called a real number. A number which is defined is called a real number. So defined number means denominator value not equal 0. If denominator value equal to 0, then we say that that number value is infinite, or we say that does not define. So a number which is defined is called a real number. So now another definition of real number system is, so union of rational and irrational numbers is called a real numbers. Union of rational and irrational numbers is called a real numbers. So R equal to Q union Q dash, Q union Q dash. So all rational numbers and irrational numbers are called real numbers. All rational numbers means all natural numbers, whole numbers, integers. So these all are rational numbers. So rational and irrational numbers are called real numbers. So the numbers which are defined also are called real numbers. So the set R will include all rational numbers, real numbers, and all algebraic numbers, that is pi, e, some constant values we know, pi equal to 22/7. So it is a real number. E value exponential 2.7 something is there, so that one, so real number. H, Planck constant H, so lambda. So this way we define constant values also real numbers, constant values also real numbers. So we know one number system, that is a complex number. So complex number is the form a plus ib form. So and a comma b belongs to R, a plus c equal to a plus ib, such that a comma b belongs to R, I square equal to -1. So in the a plus ib, a comma b are real numbers, and a is called real part, b is called imaginary part. Imaginary part means that value not defined. So a plus ib number is called complex number. So next number system, prime number. So what type of numbers are called prime numbers? So prime number definition is a number which is divisible by one and itself only. A number which is divisible by one and itself only is called a prime number. So prime numbers are start from 2, 3, 5, 7, 11, 13, 17, so on. So this way we define prime numbers start from 2, 3, 5, 7, 11, 13, 17, so on. So next, composite numbers. So composite numbers means the number which has 2 or more factors is called composite, or a number which is not prime is also called a composite number. So these numbers are start from 4, 6, 8, 9, 10, so on. 4, 6, 8, 9, 10, so on. These numbers are called a composite number. So now we know prime numbers start from 2 and composite numbers start from 4. So now what is 1? So 1 is prime or composite. So 1 is neither prime nor composite. 1 is neither prime nor composite. So what is 1? So 1 is called unit. So unit element or unit distance. Unit distance means what is that value? 1. So the distance value is 1, is called unit distance. Unit means that value is 1. So 1 is called unit. It is neither prime nor composite. So this way we define total number system. So number system, first natural numbers, whole numbers, integers, next rational numbers, irrational numbers, real numbers, complex numbers. So what is the relation between these total number system? So first start with n. All natural numbers are whole numbers. Whole numbers are integers. Integers are rational numbers. Rational numbers are real numbers. Real numbers are complex numbers. So one set is subset to the another. So it is the relation between the number system. N is subset of W, is subset of Z, is subset of Q, is subset of R, is subset of C. It is the total number system. So now real analysis. So real analysis. What is the meaning of analysis? So analysis means, so we read the topic. Or in that real number system. So for development of real number system, we define some axioms on the real number system. So for development of real number system, we define some axioms on real numbers, and those axioms are real number extended axiom, real number extended axiom. So next, ordered axioms. So next, field axioms. So completeness axiom. So now real numbers extended axiom. So real numbers extended axiom statements is, So real number system have at least two elements. Real number system have at least two elements. So it is extended axiom. So next, ordered axioms. Ordered axioms. So the axioms which are defined with the symbol less than or greater than are called ordered axioms. The axioms which are defined with symbol less than or greater than are called ordered axiom. So here we define less than symbol. So first, let a comma b belongs to R. A comma b are two real numbers. So what is the relation between these two means? Either a less than b or b less than a or a equal to b. So either a less than b or b less than a or a equal to b. So three types: a less than b or b less than a or a equal to b. So this property is called law of trichotomy. So this property is called law of trichotomy. So next one is, so a less than or equal to b and b less than or equal to a, then we say that a equal to b. A less than or equal to b comma b less than or equal to a, then we say that a equal to b. So now third one, a less than or equal to b comma b less than or equal to c, then a less than or equal to c. A less than or equal to b comma b less than or equal to c, then a less than or equal to c. So it is called a law of transitivity. It is called a law of transitivity. Next, O4. So if a less than or equal to b, then we write a less than or equal to b, then we write a plus c less than or equal to b plus c. A plus c less than or equal to b plus c. So next one, if a less than or equal to b and 0 less than or equal to c, then ac less than or equal to bc. So if c is here positive or equal to 0. So then AC is less than or equal to BC. So these five properties we define with the symbol less than, and these five properties are called ordered axioms. These five properties are called ordered axioms. So real number system satisfies these five properties. So we say that real number system is ordered real number system. Ordered real number system. Ordered real number system. So now field axioms. So field axioms means before going the field axioms, so total field axioms are 11. So in these 11, so first we define some axioms. So first one is the closure. Closure is a plus b belongs to R. Next we define associative. A plus of b plus c equal to a plus b plus c. So ABC belongs to R, associative. Identity, a plus 0 equal to 0 plus a equal to a. So here 0 is additive identity and a belongs to R. Next, inverse. So here we define with respective addition definitions. So inverse, a plus of minus a equal to minus a plus a equal to 0. So minus a is additive inverse of a. Next we define commutative, a plus b equal to b plus a. So here we define total 5 properties. So first closure, next associative, next identity, inverse. So these 4 properties satisfied, then we say that set form group. So group satisfies commutative, then we say that it is commutative group or abelian group. So abelian group means the set satisfies, non-empty set satisfies with the binary operation closure, associative, identity, inverse and commutative. So 5 properties satisfied, then we say that non-empty set is called abelian group. So here field axioms, F is non-empty set, plus comma dot b, two binary operations, then F comma plus is abelian group and F minus singleton 0 comma dot also abelian group, and distributive laws are satisfied, then we say that f comma plus comma dot is a field, means f comma plus is abelian group, means 5 properties with respective multiplication, 5 properties, 10 properties over 11th property is distributive loss. So distributive loss also satisfied, then we say that, so that set is a field. So here real number system satisfies total 10 field axioms, total 11 field axioms. Real number system satisfies total 11 field axioms. So rational numbers also satisfies, complex numbers also satisfies. So here real number system is called ordered field. Real number system is called ordered field. So here one definition. So modulus. So what is the definition of modulus? So modulus means we write mod x or mod a. So that a value is either, suppose mod a value is either positive or negative, then we will take positive. So how we will take that positive? So here the definition. So we define mod a equal to a if a greater than or equals 0, and mod a equal to minus a if a less than or equals 0. So here we say that mod a equal to a if a greater than 0, a greater than 0. If a is positive, then mod a value a. So if a less than 0, then mod a value minus a less than 0. A is negative, then mod a value is minus a. Suppose we want mod minus 2. Mod minus 2 means what is its definition? Minus of minus 2. So minus of minus 2 means we get the result is positive. So this way we define mod function, modulus value. So we define mod a equal to a if a greater than 0, and mod a equal to minus a if a less than 0. So here mod a is called the absolute value of a or modulus of a, absolute value of a or modulus of a. So here some properties are there. So for all a belongs to R, then mod a is greater than or equals 0. So a is any real number, then mod a value is greater than or equals 0. Second property, mod ab equal to mod a into mod b we write. Mod ab equal to mod a into mod b we write. So now third property, mod of a plus b is less than or equal to mod a plus mod b. Mod of a plus b is less than or equal to mod a plus mod b for all a comma b belongs to R. So this way we define mod function. Mod a equal to a if a greater than 0, mod a equal to minus a if a less than 0. So next, interval. So what is the interval? So intervals, we know closed interval, open interval, this way we define. So interval definition is, first, let a comma b belongs to R. Let a comma b belongs to R and condition a less than b. A comma b belongs to R and condition a less than b. Then x belongs to R such that a less than or equal to x less than or equal to b. Set is called a closed interval of a comma b. So x belongs to R such that a less than or equal to x less than or equal to b. Set is called a closed interval of a comma b. Next, x belongs to R such that a less than x less than b. Set is called a open interval of a comma b. Open interval of a comma b. So open interval means we will take open bracket. Closed interval means we will take closed bracket. So now what is the difference between this open interval and closed interval means? In the open interval, x value lies between a and b only. In the open interval, x value lies between a and b only. In the closed interval, x value lies between a and b and also equal to a comma b. X value lies between a and b and also equal to a comma b. So open interval means x value lies between a comma b only. Closed interval means x value lies between a comma b and also equal to a comma b. So it is the difference of open and closed interval. So this way we define some another interval. So left open, right close interval, right open, left close interval. So closed, left closed to infinity interval. So left open to infinity interval. This way we define the intervals. Again, one definition is there here. So length of interval. So length of interval means B minus A is called length of interval. B minus A is called length of interval. So if the length is finite, then that interval is called finite interval. So if the length is infinite, then that interval is called infinite interval. So length is finite, that interval is called finite interval. Length is infinite, then that interval is called infinite interval. So here close interval AB, open interval AB, left closed, right open. These intervals are finite intervals. Next, A to infinity intervals. A to infinity or minus infinity to A intervals are infinite intervals because there the length is infinite. So next definition of upper and lower bounds of a set. Upper and lower bounds of a set. So let S be non-empty subset of real numbers. Let S be non-empty subset of real numbers. So if a real number m satisfies s less than or equal to m for all s belongs to s, then m is called an upper bound of s and the set is said to be bounded above. So here s less than or equal to m. S less than or equal to m for all s belongs to s and m belongs to r. Then s is called a upper bound of s, and if the set has upper bound, then we say that it is bounded above. If the set has upper bound, then we say that it is bounded above. So next one definition, if a real number m satisfies m less than or equal to s, m less than or equal to s for all s belongs to s, then m is called a lower bound of s and the set s is said to be bounded below. So s less than or equal to m, then m is called upper bound. S greater than or equal to m, then m is called lower bound. S less than or equal to m, then m is called upper bound. S less than or equal to s greater than or equal to m, then m is called lower bound. A set has upper bound, then we say that it is bounded above. A set has lower bound, then we say that it is bounded below. So the set S is said to be bounded. So boundedness definition or bounded set definition. A set is S is said to be bounded if it is bounded above and bounded below. So a set S is bounded above and bounded below, then we say that it is bounded set. It is bounded set. Or another definition, thus S is bounded if there exist real numbers small m and capital M such that small m less than or equal to s less than or equal to capital M. So means small m less than or equal to s less than or equal to capital M means s less than or equal to capital M, then capital M is upper bound, and small m less than or equal to s, then small m is lower bound. Means it is the set S is bounded above and bounded below. So we say that it is bounded. So supreme and infimum of set. Supremum and infimum of set. A set S be a non-empty subset of R. So if S contains a largest element K, so that is K belongs to S and S less than or equal to K for all S belongs to S, then we call K is supremum or the maximum of S, or it is also called least upper bound of S. We write K equal to supremum S or maximum S. So in the set S, K is the largest element. So then that element is called a largest value or maximum value or supremum of the set. So if S contains a least element M, So that is M belongs to S and S greater than or equal to M for all S belongs to S, then we call small m is infimum or the minimum of S or greatest lower bound of S, and we write K equal to infimum S or minimum S. So in the set small m, m is least value, then small m is called small m is called minimum value of S or infimum of S. Suppose set has two values in the set S. In the set S, largest value is called supremum or maximum value. In the set S, least value is called minimum value or infimum S. So these largest and minimum values, least values are exist in unique in a set, means supremum and infimum are uniquely exist in S. Supremum and infimum are uniquely exist in S. So now here we define completeness axiom. Completeness axiom. Every non-empty subset S of real numbers is bounded above has least upper bound. So in other words, supremum S exists and is a real number. So every non-empty subset of real numbers is bounded above has least upper bound. So it is the completeness axiom. So this axiom is satisfied by real number system. So therefore real number system satisfies total 4 axioms. First one is real number extended axiom. Second one ordered axioms. Third one field axioms. Fourth one completeness axiom. So fourth one completeness axiom. So two real number system satisfies total 4 axioms. So we say that it is complete ordered field. Real number system is complete ordered field. Real number system is complete ordered field. So rational numbers also satisfy these 4 properties. So Q also called complete ordered rational field. Complete ordered real field is real number system. So complete ordered rational field is rational number system. So these two systems satisfies total these 4 properties. So now some examples on supremum and infimum. So first if a comma b belongs to R, then A less than b. So a comma b are real numbers and A less than b. Then supremum of closed interval AB, supremum of open interval AB is b, right side value. So infimum of closed interval AB, so infimum of open interval AB is left side value A. Here the condition is A less than b is given. So supremum and supremum is right side value in the interval, infimum is left side value in the interval. So next example, A equal to R belongs to Q such that 0 less than or equal to R less than or equal to root 2. So means R is a rational number and R value lies between 0 and root 2. 0 and root 2. So then, so what is supremum, what is infimum? So here the set values are start from R is any real number and R value lies between 0 to root 2. R value lies between 0 to root 2 means in that set least value is 0 and highest value is root 2. So least value is called minimum or infimum, highest value is called maximum or supremum. So supremum of A root 2 and infimum of A 0. Next one problem. So that set A equal to n square such that n belongs to n and condition n greater than or equal to 3. N greater than or equal to 3. So set elements are n square. Set elements are the form n square and n value is greater than or equal to 3. So what are the elements of the set? Start with 3 square, 4 square, 5 square, so on. 3 square means 9, 4 square means 16, 5 square means 25, 6 square means 36, so on. So elements of the set start from 9. So what are the least value and what is the highest value in the set? So set elements start from 9 to infinity. So 9 to infinity means least value is 9, highest value is infinity. So infimum 9, minimum value, highest value infinity does not exist. So the set has only minimum, means lower bound. So we say that it is bounded below. So it is bounded below. Next example, the sets integers and rational numbers have no maximum or minimum. Suppose we will take the set of all integers Z set. Elements are 0, plus 1, minus 1, plus 2, minus 2, so on. So the numbers are minus infinity to plus infinity. So least value minus infinity, highest value plus infinity, means supremum and infimums are does not exist. So we say that no maximum, no minimum. So the set n has no maximum, but minimum of n equal to 1. Natural number set, elements are 1, 2, 3, 4, so on values. So in those, least value 1 and highest value infinity. So minimum or infimum value 1. So there is no maximum or supremum. So it is bounded below set. So next one problem, consider the set n into minus 1 to the power n. So such that n belongs to n. So here the values minus 1, 2, minus 3, 4, minus 5, so on values are there. So here also some negative values are there. So minus 1, minus 3, minus 5 means up to minus infinity, 2, 3, 6, so on means up to plus infinity. So minimum value minus infinity and maximum value plus infinity. So here also supremum infimum does not exist. So next one property, Archimedean property. So if a greater than 0 and b greater than 0, then for some positive integer n, we have na also greater than b. So it is called a Archimedean property. So here now one definition, neighborhood. So what is the definition of neighborhood? Neighborhood. So neighborhood means nearest values. Neighborhood means nearest values or belonging values. Nearest values are surrounding values. Nearest values are surrounding values. So first epsilon. Here we define first epsilon. Epsilon is a least positive integer. Means its value is greater than 0. Epsilon is least positive integer. Means its value is greater than 0. So now epsilon neighborhood, we define epsilon neighborhood. Let epsilon greater than 0 and x belongs to R. Then an open interval x minus epsilon comma x plus epsilon is called epsilon neighborhood of x, and x minus epsilon comma x plus epsilon minus singleton x is called deleted neighborhood of x. Deleted neighborhood of x. So an open interval x minus epsilon comma x plus epsilon is called epsilon neighborhood of x. In that neighborhood we delete x value, then that neighborhood is called deleted neighborhood of x. So example, epsilon equal to 0.1 greater than 0 and 2 belongs to R, then x minus epsilon comma x plus epsilon equal to 2 minus 0.1 comma 2 plus 0.1. So that equal to 1.9 comma 2.1 is called a epsilon neighborhood of 2. So here the interval, open interval 1.9 comma 2.1. So this open interval 1.9 comma 2.1 is called a epsilon neighborhood of 2. Means 1.9 and 2.1 values are nearest to 2. So it is the neighborhood definition. So this neighborhood definition we will take in the definition of limits. So in the limit definition we will take neighborhood definition. So limit values are approximate values. So next, limit point of a set. Limit point of a set. So let S be a non-empty subset of real numbers and L belongs to R. Then L is said to be limit point of S if there exists every neighborhood of L contains infinitely many points in S. So let S be non-empty subset of real numbers and 1 belongs to R. Then 1 is said to be limit point of S if there exists every neighborhood of L contains infinitely many points in S. So every neighborhood of L contains infinitely many points in S. Then we say that L is limit of the set. So now open interval L minus epsilon comma L plus epsilon intersection S equal to infinite, then L is called a limit point of S. So L minus epsilon comma L plus epsilon intersection S equal to infinite, then L is called the limit point of S. So here L minus epsilon comma L plus epsilon intersection S equal to finite, then L is not a limit point. So if that value finite, then L is not a limit point of S. So here see one example. So let epsilon equal to 0.1 greater than 0, S equal to natural number set, and L equal to 2 and L equal to 2. So L minus open interval L minus epsilon comma L plus epsilon intersection S equal to. So 2 minus 0.1 comma 2 plus 0.1 intersection N equal to 1.9 comma 2.1 interval intersection N. So in the interval and the natural numbers have one common value, that is 2. So only one common value 2 means it is a finite set. So if this intersection value is finite, then L is not a limit of natural number system. L is not a limit of natural number system. So in the next problem, let epsilon equal to 0.1 greater than 0, S equal to R, L equal to 2, and the interval 1.9 comma 2.1 intersection R. So in between 1.9 and 2.1 we define infinite real numbers. So in between any two real numbers we define infinite real numbers. So 1.9 comma 2.1 intersection R equal to infinite. So we say that L is limit point of R. L is limit point of R. So by this definition we say that natural numbers have no limit points. Same way integers also have no limit points. So rational numbers have limit points and real numbers also have limit points. So here we define one theorem. That theorem we say that Bolzano-Weierstrass theorem. So every infinite bounded set has at least one limit point. Every infinite bounded set has at least one limit point. So it is the only statement of Bolzano-Weierstrass theorem. So thank you.